Okay, good day everybody, and here we are following up on the previous video that we started, continuing our series on the algebra, the subject of the formula. And today we are going to specifically look at how to make the subject of the formula, but using transposition, working on transposition. That's one of the techniques, right? So just to do a little recap, let's first look at the characteristics of the subject of the formula, which we did last time, but just again to emphasize, if you didn't look at that video, you could always look back at it, but here we're going to just go through it quickly. So firstly, we said that the subject of every formula in any given formula must stand alone, it must be positive, and it also has to be in the numerator position. Good. And here we just have a simple example. Supposing we give you the equation or the formula A is equal to length times width, and this is the area, the formula to calculate the area of a square or a rectangle or certain quadrilaterals. Let's look at it like that. So in this case, we know that the A above is the subject of the formula because it exhibits the three characteristics of a subject. What are those three characteristics again? They're right here. It must stand alone, right here. It must stand alone, it must be positive, and it must be in the numerator. The A here is standing alone, the A here is positive, and the A here is in the numerator. And just to throw it out there, I mean, making this topic is a very interesting topic, is a very interesting, a very cool thing to do. But just for we to know, somebody might be asking, why do we need to make the subject of the formula? In maths, I'm telling you, this could be applied anywhere, anyhow. And I'm just keeping it mathematically here. We could always explore this in the future in many other ways. It is common for we to calculate the area, and I'm working with this formula here. We can be asked to calculate the area of a rectangle, let me say. We're given the length, we're given the width. So let me say we know the length is 8 and we know the width is what? 4. And if we ask to calculate this, so for example, we have 8 and we multiply that 8 by 4. And this will give us the area. This will give us the area of 32, whatever unit squared, because it's the area. And this is just a brief example. So we have 32. That's the area. But when we do in algebra now, it's not like in the primary school. In the primary school, this might be very common. They might be very common that they ask us to find the area or to calculate the area. But at the higher level, tertiary, secondary, and wherever, oftentimes, sometimes it's not the length and the width that we're given. Sometimes they give us the area and they give us the length. And then we now have to find the width. And this is where the subject of the formula comes to play. Because now we have to make sure that we could find out what is that W. I'm just giving you this for perspective. I don't want to dig too deep into this. But in the future, these are things we have to be at the top of our minds. I don't want us to keep it as an isolated thing. The subject is the subject and the subject is for itself. No. The reason why we find the subject is because we always seek to find what is the unknown. And the unknown would not always be the area. Now, you know, it could be the length, it could be the width. And if that's the case, as we established last class or last video, is that if we ask to find the width, then more than likely they will provide us with the length and the area, and then we have to do our maths. Sometimes they might ask us to find the length. If they ask us to find the length, then more than likely they will feed us with the area and the width, and so on and so forth. And of course, if they wanted to find the area, more than likely, then they will provide you with the length and the width. So that's just so that you know. Let's look at the signs. Understanding the signs is a very tricky and important thing to do. Before we go into transposition, let's just clear this quickly. You must understand what sign belongs to which variable or which constant. The positive sign is often said to be understood when it's not shown. And all this is saying is that if there is no positive sign shown, then you know that there is a positive sign. Of course, when it's shown and you know it's there. But when it's not shown, then it is there. The negative sign is not understood. So for we to know something is negative, it must be shown. It must be written. And where does the sign usually goes? In front of that entity. So if we want to know the sign of the number 2 here, let's say for example, we always look in front of the 2. We look in this area here. We cannot look behind. This positive sign here does not belong to the 2. This positive sign here belongs to the 3. The 5, if we want to know the sign for the 5, we don't look after the 5, we look before the sign. So if we want to know the sign for the 5, we have to look in front here. And as I said earlier, if there is no sign, then we say that that sign is understood to be positive. So in front here, we know that our 2 here is positive, our 3 is positive, our 5 is also positive. Number 2, if you look at the second example here, our 6 here would be positive. Our 8 is evidently negative. Look at the sign in front of it. We always look for the sign in front of it. The 2 here is also negative. We can see that negative sign there, that negative 2 here. Good. The F here is negative. It's given as negative. We can see the negative sign. Remember, the negative sign is not understood. So if we want to know the sign, we just have to look in front. If we don't see nothing, then we know it is positive. You would see why this will become a very important thing to understand just now. And here we see the E. The E is clearly positive because there is a positive sign in front of the E. And the W here is also positive. Even though there is no sign, remember what I said just now there? If there is no sign, it is understood that it is positive. With this in mind now, let's dig deep into the concept of transposition. There are 2 ways to transpose, and well, rather, I know 2 ways to transpose. I prefer one more than the other, but I will show you both ways, and then I will stick to my preferred way. Good? To make something the subject of the formula, remember what I said earlier, there's always 3 questions we have to keep asking, and the answer to those 3 questions have to be yes. In these 4 scenarios here, which I will do, and you will just follow with me, then I'll give you some to do on your own. I'll give you some time. Well, it's a video, you would stick, and then you will look at the answers, right? Not stick, but pause, you know what I mean? So you make t the subject of the formula. All this is asking us here is to make sure that the t is alone, the t is positive, and the t is in the numerator. If we could achieve those 3 things with t, then we could safely say that the t is now the subject of that formula. Or, to dumb it down even further, we want the t to be on one side of the equal sign all by itself, positive and in the numerator. That's another way we could look at it. Okay, good. So let's look at today, as I said, we're focusing strictly on transposition. So let's do the first one. We have 4 to do. Let's do the first one. So as I said, I will show you 2 ways to do it. The second way, or one of the ways to do it, to make the t the subject of the formula, basically we have to get rid of the 4. Our highlight today is transposition. But as it is, we could ask t a question. Is the t positive? Yes. Remember, if it's standing there, the sign is in front here, and we say if the sign is in front here, if there is no sign, it is understood that it is positive. Is the t in the numerator? Yes, it is in the numerator, because we can easily throw all this here over 1, and that will be t in the numerator. And is the t standing alone? That's the problem. No standing alone. So to rectify this here, all we want to make sure is that the t is standing alone. What is stopping that t from standing alone? That is Mr. 4, Mr. Positive 4. So I'll show you 2 ways. To get rid of the 4, we can do one of 2 things. First of all, we have to understand equation. There is a simple law when it comes to equation. Whatever we do on one side of the equation, we do on to the other side. This 4 here is positive. So if we want to get rid of that 4, all we have to do is subtract 4. And because we subtract 4, again going back to the laws of equation, because we do it on one side, we do the same thing on the other side. So we subtract 4 there. So this 4 naturally will cancel off this 4. A positive 4 and a negative 4, that gives us 0. And on the other side, we have 6 minus 4, in which case we could actually compute. So 6 minus 4 will actually give us 2. And that does it. That solves the problem. So t is equal to 2. And then we're going back to t. Is the t standing alone? Yes. There's no longer 4 with it. Is the t positive? Yes. No sign in front of it, remember, means that it is understood that it is positive. And is the t in the numerator? Yes, it is still in the numerator. The only problem with it that didn't exist with the t, it was that it was not alone. And we verified that, we rectified that. And this is one way to solve it. Then I will show you another way. And if I must be honest, the other way is my preferred way. And that's what I will stick to for the rest of this video. The other way to look at it is this. If we have the 4 here, we simply bring the 4 on the other side. This is my preferred method. And whatever sign is in front of the 4, or whatever sign is in front of the entity that we transpose in on the other side, or the entity that we bring in on the other side of the equal sign, is changed. So if it is positive, when it's on the other side, it becomes negative. If it is negative, when you bring it on the other side, it will now become positive. So this here will leave us now with t equal to 6 minus 4. Same thing like we did just now there, because look at it, it's positive here. When we bring it over, it is negative. And of course, when we solve here, we will end up with 2. So t is equal to 2. And that is what transposition is all about. So again, in a nutshell, to transpose, we simply bring something on the other side of the equal sign and we change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. And sometimes we have to do this several times until we achieve our goal, which is finding the subject. And that is making t stand alone. And one of the things we could do with this sometimes, it's not always applicable, but sometimes we could. And in this case, we can. If we know that t is 2 and we replace t with 2, we will see that this equation here is true, because 2 plus 4 is indeed equal to 6. And we could consider that a way in which we could verify that our answer is true. So this is true. But again, as I said, it wouldn't always be applicable because sometimes we just end up with another algebraic expression. Let's go on. So here we have example number 2. So in example number 2, we have 5 plus 8 plus t. And again, the aim is to make the t stand alone in this case, again, because as we can see, it is already positive and it is in the numerator. The only problem here with t that is not the subject is that it has company on his side. It have an 8 and it have a 5. And of course, the 20 is alone. If we go to make 20 the subject, as it is already, because the 20 is alone, it's in the numerator and it's positive. But they ask us to make t, we find in t. So let's go again. Here we have 5 and 8. These two numbers can be computed. So I recommend that you solve it. But even if you choose to do it later, it's okay. But I will simplify it. So I know that 5 plus 8 is supposed to give me 13. Hope I don't make a mistake there. Sometimes it's the easy thing that will skill us, not the hard things. Right. So I know that 13 plus t is equal to 20. And this is in a suitable position here now for me to bring over. So remember, I want the t to be for itself, so all I have to get rid of is the 13. So I bring my man 13 on the other side here. And again, it is understood that the 13 here has a positive sign. Remember, if there is no sign in front of it, it is understood to be positive. So when I transpose it, that positive now will become negative. Very important. Easy does it. So then we have t. Don't interfere with the sign of the 20. I've seen students put the 13 in front of the 20 and they change the sign of the 20. They make the 20 negative. But we didn't do nothing with 20, so they have to leave the 20 alone. So 20 stays as itself, and the 13 that was positive over here, when we bring it over, it is now negative over here. So that is 20 minus 13. And that will leave us with t equal to 7. Yes? And if we want, again, as I said, it's always good in maths. I will always recommend that you prove your answer. So if we bring this t equal to 7 at the top here, we would see that 5 plus 8 is 13, as we just got there. And we know that t is 7. So 13 plus 7 is indeed 20. And that is a good equation. That is true because it's equal on both sides. And that is all the equation is saying. If the equation is telling you that this is equal to this, when you work it out, it has to be equal. And 20 is equal to 20. We can't do that. Let's try the next one, number 3. So number 3, we have a little interesting scenario here. We have 32 minus t is equal to 12. And I know right now you probably think that we always have to get rid of everything besides t. But notice we have a problem with t. The subject must be positive, the subject must be standing alone, and the subject must be in the numerator. As it is here, with the t has two things that we have to fix. The only thing that is true about t so far that we need is that it's in the numerator. That's good. We don't have to do nothing there. But we must rectify it being positive and it standing alone. So in this case, we have to move the t. Yes, believe it or not, we have to transpose the t. And why do we do this? Because we understand that when we transpose, there is a change of sign. And that's what we want. We want this t to be positive because that is one of the criteria, one of the characteristics of our subject. Our subject must be positive. And because we're dealing with transposition, this is the way I'm going to do it. In the future, in the upcoming videos, when I teach you about multiplication and cross multiplication and division, you would see that there is something else we could do here. But I wouldn't spoil the bubble. So that will leave us with 32 is equal, remember we send the t on the other side, so the 32 is there now for itself, is equal now to 12 plus, now our t is positive because we transpose the t. So now we fix the negative problem. All now we have to make sure is that the t is standing alone. And now to do that, we must get rid of the 12. So I will send the 12 on the other side and I will put it here. As a matter of fact, for the sake of it, for the fun of it, I will put it on the other side. So you will see what is happening here. You need to understand that you need to understand signs. So it doesn't matter where I put it. Let me put it after the 32. So here I will have the 12 is positive here. When I bring it over here, the 12 now will be negative. So the 12 is negative, the 32 is positive, and guess what? It will still remain positive. So that is 32 still positive. Nothing happened to the 32. And now my t is all alone. Oh shit, I put a f. My t, sorry, not f. How did I put a f? Good. So my t is all alone. And that is it. That solves the problem. And of course, we could solve the other side. Minus 12 plus 32 is actually 20. If we have problems with signs, we could always review the number line so we understand how we add and subtract negative numbers. Or you could see this as 32 minus 12. If you put the 12, the minus 12 in front of the 32, that's what we have here. 32 minus 12. Although that's not the aim today. And again, we could verify this. We just put the 20 above and we have 32 minus 20 indeed will equal 12. And let's do the fourth example. And for the fourth example, we have 7 plus t minus y is equal to 10. And here we have again some shuffling to do, but we only want t to be the subject. So that's what we do. To make t the subject here, again, we have to make sure that it is positive, it is standing alone, and it is in the numerator. What do we have here? We have a 7 with the t, we have a y with the t. We want to get rid of the 7, we want to get rid of the y through transposition. So firstly, I will get rid of the 7. I will send the 7 on the other side. The 7 as it is here is positive. When I send him on the other side, it will be negative. So that should leave me with something like t minus y. And I'm jumping, now let me not jump no gun here because I wanted to see all these steps along the way. So 7 minus y is equal to 10 minus 7. I was going to put the answer there one time. I was going to put 3. But then some person might wonder where the 3 come about. So if I bring the 7 over, remember that will make it negative. So then that we have 10 minus 7. And 10 minus 7 is the same as 3. So now you know where the 3 comes from, right? So that's the same as 3. Good. And now I want to get rid of the y because remember t is my aim. I want to make t the subject. So I get rid of the y and again I do the same thing. I send over the y on the other side and that will leave the t all alone, all positive and in the numerator. Good. So when the y goes over, it is negative over here. So when it goes over, guess what? It becomes positive. So that leaves me with 3 plus y. And that is our answer. That is as far as we could go. We cannot go further than that because we don't know what is y, so we cannot solve. Good? And that's it. Of course, sometimes they would give us y. They could tell us if y is equal to 4, find what is t, and then we would know that t is 7 if y was 4, right? But that's that. Very good. So let's move on now. That's basically the lesson. And now it is your turn. Do some practice now. So of course, this part, you could pause it. You could pause and then you solve. But this is a video, so I will go right ahead. But you could pause it here, see if you could work it out, and let's see if we get the same answer. Wouldn't that be cool if we get the same thing? I think so. So let's move on. So here we have the solution, so I'll just work it out quickly. So again, notice now we're finding y and not t. So don't get caught up. We want y to be the subject. So as it is here, y is negative. So yes, I have to do some shuffling around. So I'm sending y on the other side because I want the y to be positive, right? So that kind of leaves me here with 0 equal to 4, because I took out everything on that one side. So there is a 0 left there. 4 plus t, and now I have plus y. Yes? And now I want to get rid of everybody else. So I send my 4 over here, and I send my t over here. And I'll do the 2 steps in one, but you could do one at a time. Again, you're just looking to see if we have the same thing. So when I say notice that the 4 is positive, so I know when the 4 end up on the other side, it has to be negative. Likewise, the t is positive here, so when I send the t on the other side, the t has to be negative. So then we know that minus 4, yes, and minus t, yes, is equal to y. And that is our answer. And sometimes most persons, a lot of people prefer it on this side. I am not particular about that. It's the same thing, really and truly. So if you want, you could just write it the other way around. So you could say y is equal to minus 4 minus t. But again, as I said, it doesn't matter. It doesn't matter. Minus 4 minus t is equal to y. Y is equal to minus 4 minus t. As long as you ain't changed nothing, really. And that's our answer. Number 2 here, very simple. We want y to be the subject, so we just get rid of the x. We send the x on the other side. And that will leave me with y is equal to, remember I didn't interfere with nobody else, so the r will still be r, minus q will still be minus q, and the x, which was positive over here, when it goes on the other side, it will now be negative. And that is our answer. Easy does it. Hope you got that. Let's try number 3, then number 4, and call it a wrap for today. So number 3, we want y to be the subject. So again, for y to be the subject here, all we need to do is get rid of this 4 here. So I will send the 4 on the other side. Remember, the subject always have to be alone, positive, and in the numerator. That's all we have to do. So that's all we have to make sure that is happening with whatever we make in the subject. Alone, positive, numerator. So I send the 4 on the other side. Note that the 4 is positive. When I send him on the other side of the equal sign, it will become negative. That's the thing behind transposition. You always have to remember that. When we transpose, you change the sign with whatever you bring over on the other side. Good? So that will leave us with z minus 7 minus 4, because it's transposed. Positive over here, when we bring it over the equal sign, it becomes negative. So z minus 7 minus 4 is equal to y. And here we could do one thing further to simplify. We could actually compute minus 7 minus 4. So if we, well, when I would say compute, simplify. So minus 4 minus 7 is the same thing as z minus 11 equal to y. And that is our answer there. Good. And last but not least, we have number 4, y plus 9 is equal to 12. So then, again, I just want to get rid of the 9 because I want y to be the subject. So that will leave me with y is equal to, when I bring over the 9, I have 12, good, minus 9. Why minus 9? Because again, it was positive here. Look at it here. It's positive here. So when I bring it over, remember transposition, positive become negative. If it was negative, then it will become positive. And that will leave me with y simply being equal to 3. And again, this is one we could prove. So if we put back 3 instead of y here, if we put our y, because y is 3, we could always replace the value of y for 3. And if that's true, then 3 plus 9 indeed supposed to give us 12. And this is the case here. 3 plus y gives us 12. 3 plus 9, sorry, gives us 12. So that is a wrap for today. That will be the end for today's video. So you can go back and review your transposition, go through the video slowly if you did not get it, or leave a question in the comment section if there was anything that was not clear. And in the future, in our next video, we are going to look at another rule. We're going to look at how to get rid of multiplication and division to find the subject of the formula. And hopefully we could also maybe tackle cross multiplication one time. So for today, make sure to share, like, and subscribe, and feel free to ask any question that is not clear. You do enjoy the rest of your day. God bless.